Welcome to another tech video. So today we are going to be looking at power injectors. So power over Ethernet injector for a Wi-Fi access point. So why might you use one of these? So normally when we're at a client site, if we're connecting lots of PoE devices, i.e. VoIP phones, we would power them from a PoE switch. However, in some circumstances, for instance, where you've got your voice, i.e. your phones, on one broadband service and your data, i.e. your PCs and laptops, on another service, and the data is completely separate, then if you want to save some money by not investing in a PoE switch, then potentially using a PoE injector is a useful piece of kit, and it will save you money. So for instance, if you're talking 24 port PoE switch, then realistically you're adding £300 onto your switch cost, when you could be having a 24 port non-PoE switch for around about 200 quid, and then if you've got your access point, which would be connecting into your data switch, i.e. the non-PoE one, then rather than investing in a PoE switch, even a small PoE switch, if you buy a PoE injector, then you'll save yourself some money. So the one that we're going to be looking at today is from Ubiquiti, and we're going to be using it on a Draytek AP 912C access point. And all we're going to do is we're going to run through the hardware setup, so what you need to do to set the hardware up and how to connect it, and then we'll go through to make sure that we can see the access point online. Now, the important thing here is Draytek do their own PoE injector, which is I think £38 for a single injector, whereas the Ubiquiti one, which is the AF standard in PoE, is £15. So effectively Draytek are charging an awful lot more, whereas you can buy a similar device that will adequately power your unit for literally more than half the cost. Now, the Ubiquiti PoE injector that we've got is Gigabit Ethernet, so that's the full 1 gig Ethernet port on there. You want to be careful if you are buying PoE injectors to make sure that it does say Gigabit, because there's a lot of them that are quite cheap that are fast Ethernet, so 100 megabit basically. So make sure you do your research before you purchase one. Okay, so without further ado, let's now have a look at the hardware setup, and then we'll move straight into seeing if we can find the device on our network, and then have a look at some basic configuration options. So here we've got our Draytek access point, which is the 912C. We've got our Ubiquiti 48 volt PoE adapter. So this is the AF and AT version. And as you can see here, they've got it connecting into a router or switch, which is correct, and then out into the access point. And we've got a UK power cable, because this Ubiquiti device comes with a European plug. So if we get this open, we can put that to one side. So it's one of the tri-point connectors. This is a plate that unclips, so you can screw that to the wall and then mount this onto there if you want to, but we're going to pop that back on there. Okay, so the first thing that we want to do is we're going to take out the access point. As you can see here, we've got the AP. We'll leave all the cellophane on it for the moment. In here is a power adapter that we're not going to be using, so we don't need that, because we're going to use a PoE injector. So we're going to take that out and put that to one side for the minute. And then what we've got here is a standard network cable. So this is connecting into a non-PoE hub, or a switch I should say, which then connects to our pfSense router. So when you first set the device up, as you can see here, if we plug this into our LAN port, we get no power at all, because the switch that we're using is not a PoE switch. It's a standard Gigabit 8 port Netgear switch to have at home. So we can unclip that now. We can get in here, there we go. And then we're going to take our power lead, and we're going to connect our power lead, and then we're going to connect the power lead into the injector. And at the moment we're leaving that switched off, and the next thing we're going to connect our network cable into our LAN port. So we've got LAN and PoE. So LAN port is what you connect it to your network switch, and PoE is the device that you're going to be powering. So we're going to connect our LAN switch into the LAN port, and then we're going to take another network cable and we're going to connect that into the PoE port, and then we're going to connect the other end of that into our access point, like so. Okay, so there we go. So we're all set up, ready to go. So let's now get that switched on, and you should see the light. Okay, so let's switch it on. And we can now see that we've got a light on the PoE injector, and we've now got a light on our Draytek access point. If I just move that out of the way of the light, there we go. So you can see that we're now powered. Once that starts pulsing or flashing, then the device is ready to see if we can find it on the network. So that's all there is to that part. That is the basic guide of how you connect a PoE injector to your access point. Let's now move on to the system itself and have a look at what we need to do to get the device set up with the Wi-Fi name. Right, so we're going to use Angry IP Scanner and sweep the network to see if we can find it. Okay, so this could be it. Yep, that looks like it. So 192.168.0.152. So let's open that up. Okay, so here we are. Let's log on to the device. Okay, so this is the portal that you're, the interface of the device itself. As you can see here, we're on version 141. So let's go ahead and see if there's any firmware updates. Okay, and we want to find our AP912C. Okay, 141. So we've got an update. So let's download the firmware, close that, and then we can go back. We're going to go to our system maintenance. We're going to go to firmware upgrade 912C141. We're going to double click that. Now the .all file will preserve your configuration. If you rename that to .rst, that will factory restore your device. So actually let's do that. Rename, so we're going to rename it from .all to .rst, and this is going to factory reset our device. So we're going to browse for that again. Going to open that, and we're going to do upgrade. Okay, there we are. So that has now rebooted after the upgrade. So the previous password shouldn't work.
and it should be back to the default, which it is. So we log in using the default credentials of admin. And then the first option that you come to, it will ask you how you want to set your device up. So let's have a look at the options. So access point, this enables you to join your wireless devices to your existing network, whether you're going to be using it as a mesh access point. So if you're setting it up as the base unit, you would set it up as the mesh route. If you've already got a mesh route, then you would set it up as a mesh node, and then you would go into your mesh route to go in and include your mesh node as part of your mesh network. Or if you want to use it as a range extender, which will basically pick up your existing Wi-Fi connection and boost it. We're going to be using access point mode. As you can see here, it shows you how to connect it. So the internet into your router or switch, or router, then switch, and then connecting into your access point, and then you connect your devices to the access point. So we're going to select next step. This gives you the option to set your access point SSID, so whatever name that you want, and if you want to give it a password. So I'm actually going to call this test Wi-Fi, and I'm going to give it test 1234 as the password for now. Click on next step. Then we can change our admin password. So the current password is admin, so we're going to change that to something else. Once you've done that, we're going to click on next step, and this will confirm your settings. So we're not using a second Wi-Fi name at all. We're not having bandwidth limitations, and we're not using station control. We can have a look at those later if you need to. Click on finish. That will then set up the system for us. And there we go. So as you can see here, we've got our device name. So if you want to change your device name, you click on the symbol there. This is quite important. So these are some security functions. So do you want to allow management from the wireless network? So we always untick that because we want to be on a wired client before we can access the device interface. We're going to set our name, so we're going to call it test AP 01. We're going to leave our telnet server enabled. Don't worry, it's well protected. And then the TLS encryption options, what we want to do, we're going to select version 1.2 or above. Okay, and that will enhance the security from TLS version 1.0. You don't want to be using that. You don't want to be using 1.1. Minimum level is really version 1.2. And again, if you want to have an access list, so you can configure an access list to only allow clients to connect to that management interface from the IP range of your network. So we're going to say OK to that. And then we just need to wait for the device to reboot. We're going to log in with our new credentials. We're going to check our host name's updated, which is up here, and you can see it's updated. We've got our version 141. Okay, so now let's have a look at some of the other options. So we're going to go into LAN general setup. So this is a DHCP client. In other words, it's going to pick the IP address up from your router or your DHCP server, and therefore we would expect our DHCP server on the device itself to be disabled. If you've got a management VLAN, you would enable it here. We don't, so we're not going to. And again, because it's DHCP, we don't need to give it any DNS settings. The clients that pick up their DHCP addresses will have the DNS servers from your DHCP server that will issue the DNS servers to the client. Hotspot web portal, we're not going to be using that, so I'm not going to go into that today. Port control, we're not going to be using this either, so that's it in terms of the LAN setup. Central AP management, so if you've got a Draytek router that supports it, you can manage the AP device directly from the router, but because we're connecting this into a non-Draytek router network then, or a Draytek switch, then we're not going to be using this, so you can ignore it. Okay, so let's talk about the wireless setup. So if we go into the 2.4 gigahertz network or setup, you can see here we're using B, G and N. We want to leave that enabled to cover all eventualities. We're going to leave the channel details as they are there. Now if you want to configure additional SSIDs, then you can tick the box, create another SSID. If you're using VLAN tagging, then you would assign it a VLAN here. Okay, so let's talk about these options here. Isolate LAN. So what this means is that wireless clients with the same SSID cannot access wired PCs on the network. So what this means, it basically creates an isolated Wi-Fi network that those devices cannot access anything on the wired LAN. So if you tick this box, then your wireless devices are not going to be able to print to wired printers. But they will be able to see each other on that Wi-Fi network. Isolate member, so this means that wireless clients are not going to be able to see each other on the network. So if you tick that box, for instance, use case might be a guest Wi-Fi, for instance. As a guest Wi-Fi, you would tick this item here because you want to isolate the member. You don't want any wireless devices seeing any other wireless devices on the network. It's effectively creating a public network for that individual device. So that's what those settings mean. So we're not going to be changing any of those because we're going to be using it, as I said, on a customer site eventually. So we're going to say cancel to that because we've not made any changes. Then we're going to go down to security. So as you can see here, the mode is WPA3 and WPA2 personal, which is perfect. That's just what we want it set for. And we also want to make sure that we only have AES encryption supported, because otherwise if you select TKIP and AES, you will find that your Apple devices will moan that it's an insecure network. So we make sure that it's set to WPA3 and WPA2 personal with AES. We don't have any other SSIDs, but if we did, then we can configure all of those details here. We could change the passphrase, for instance. Access control, we leave it disabled, but you can specify just specific MAC addresses to connect to your Wi-Fi. WPS, we are not going to be using this because we use the passphrase. Under the advanced settings, this is where you can change the channel bandwidth, for instance, but we are going to leave all of this stuff the same. Now, one of the ones that is important is this one here where it says isolate 2.4 gigahertz and 5 gigahertz bands. So what this means basically is if you have this enabled, it means that any clients on your 2.4 gigahertz network are not going to be able to see or talk to any other clients that happen to be connected to your 5 gigahertz networks. And this is a way that you can separate the two together. So we're going to say disable for that because we want that enabled. Because we might have some clients talking, for instance, you might have an old printer that only connects using 2.4 gigahertz and all of your modern devices are connected to 5 gigahertz, and therefore if this is enabled they're not going to be able to print. So we're going to say OK to that, and that's that updated. AP discovery, we're going to leave that alone at the moment. WDS AP status, leave that alone. We're not going to be configuring any bandwidth limitations. So this lets you configure bandwidth per, or bandwidth management per SSID. Airtime fairness, we're going to leave that disabled because there's only about 20 devices on the Wi-Fi network. Station control, again, we're going to leave that off. Roaming, we're going to leave that with everything set as it is. band steering. So we're going to enable band steering. So this basically means that if there's a device that connects via 2.4 gigahertz channel, then it will try and push it onto a 5 gigahertz Wi-Fi network if it's enabled, based on the noise level. So for instance, if you are right at the far end of where your 5 gigahertz network can reach, then you will be joined to the 2.4 gigahertz until you move back into the relevant RSSI settings here. So we're going to enable that, and then we're going to move on. We're going to ignore the station list. We're going to move on to the 5 gigahertz network, and this should be set the same, which it is, test Wi-Fi. So we don't need to do anything on that. Security will be the same password that we set, and we're going to make sure that our modes are the same. So AES encryption with WPA3 and WPA2. Access control, again, we're not going to be using it. WDPS, we're not going to be using it. Advanced setting, we're going to leave things as they are, and it's already picked up the change that we made between the 2.4 and the 5 gigahertz band, so it's going to set that to disable. And then again, we don't need to change anything else on here. We're not going to be talking about the radius settings, object settings, application, mobile device management, or anything else. That is it in terms of the basic setup for a Draytek 912C access point. Okay, so let's go and have a look at our speed test. And we're going to click on Start. And what this does, this is going to measure the download and upload speeds. As you can see here, download speed 263 megabits a second, and then upload speed 23 megabits a second, because that is what our internet is capable of. So it's a good way to make sure that your access point is getting the full experience for your users. Traffic graph, again, this gives you the ability to look at your throughput on the device. And then your 2.4 gigahertz statistics, 5 gigahertz statistics are all available here. So now let's go back to our dashboard. We're now going to join our Wi-Fi network on our phone. We're recording the screen so you can see. We're going to go into our Wi-Fi settings, and we can see our test Wi-Fi. So we're going to pop in our password that we created, which was test1234. We're going to join our Wi-Fi. And there we are. So now when we go to our dashboard, which will automatically refresh, we should see that actually we've got a client connected, and it's connected me on the 5 gigahertz network, and we can see our throughput, our usage, and our link speed 585 megabits a second between the phone and the access point. Okay, so now let's do a speed test to see if I can find it. I'll go in here. We're going to run our speed test. Let's see what we're going to get. Okay, and as you can see there, we're getting our advertised 200 meg service that we're actually on a 200 meg service, so that's good. And we're getting the full speed download and the full speed upload. Okay, so now let's see what our throughput is. And there you can see 22 meg down, or 22 meg up, and 225 meg down. If we go back to our diagnostic, we can have a look at our traffic graph, and we can see that our traffic graph has increased, download and upload speed. Shouldn't have anything in here. No, we haven't, because we're not on 2.4 gigahertz, and you can see here that our transmit packets are the same. So there you have it. That's all there is to that video. If you found the video useful, give it a thumbs up. Don't forget to subscribe to the channel. If you've got any messages for us or questions for us, leave them down below. I just want to say thanks for your continued support and watching our videos, and we will see you in the next one.